Hello everyone. Today, welcome back to my videos for method 24. So the calculus 1, and the topic today is really about analytical geometry. That is 2.8, the geometrical interpretation of the derivative, section 2.8. Geometrical interpretation of derivative. And in section 2.7, we explore that what is the derivative of function. So what is a derivative? So like the derivative, it is like the slope of the tangent line. Or the instantaneous velocity. Wait, I forgot, they're gonna be page 26. Instantaneous velocity, and that's all as like the instantaneous rate of change. For this in 2.8, we can talk about like how graphs of f of x and f prime of x, how they correlated each other and how they affect the shape of each function. Are affected each other. And we know from 2.7 that if fx, then f prime of x is at the limit h of a 0 f x plus h minus fx over h. Do some algebra and the limit, we just defined what is f prime of x. So let's do an example here. Find the slope of the tangent line through the curve f of x 2x squared minus 4 at x equal to 1. So if you ever see the word, the phrase is slope of a tangent line, this means is derivative of a function at a point. So in this case, if we were just to let's just think of what we need. We need to find what is f prime of x. And f prime of 1. And what we have it as fx, and we can compute f1 with our information. So do like a limit trick. Gonna draw like a dash line here, just make sure it is better than 24. So f prime of x to like a limit h approaches in the 0. It's gonna be 2x plus h to the squared minus 4 minus 2x squared minus 4 over h. You don't need to conjugate, just to do some algebra, just get this expression in easier form. Like limit h approaches 0, make sure to expand the polynomials. It's gonna be 2 over x squared plus 2x h plus h squared minus 4 minus 2x to the squared plus 4. A lot of term will be canceled. The main purpose of doing the limit just to get h term canceled, because h is a singularity. Otherwise, it's a zero and a 0 limit. So 2x squared is canceled and 4 is canceled. So we just have is 4xh plus h squared. Gonna be 4xh plus 2h squared. Those two for there 1, 2, 3, 4, 5, 6, or 4 canceled, not 2 terms left. It's gonna be this f prime of x. It is 4x. And f prime of 1, it is 4. So this is like the slope of the tangent line. To the f of x. At x equals 1. So now we know 4. Yes. So this means like x equals 1, and since we know it's f prime x equals 4x. Now we put a function into graphs. How they're gonna affect each other. So what do they look like? Is there any relationship that we're gonna looking for? So we put into a graphical content. Perhaps this is just the XY axis, and this is the perhaps this just says f of x. It is 2x squared minus 4. So x to 1, then it's going to be -2. It's like a 0, it's -4. And the zeros are going to be zeros going to be like a negative square root of 2 and positive square root of 2. They're not on scale. Graph is not going to scale. So this is f of x. And if you know what is f prime of 1, so you know it's like a radical 2, which is a 1.414. So 1 that is under the 0. So this is just f prime of 1. Just this is f prime of 1. Actually, is this a sky blue? Light blue line is like the 2x. This is like a midnight blue, dark blue. It is the tangent line. And if we draw like another graph, it's like y equals to 4x. What do you would notice? 4x. So at x equal to 1, the derivative is above the x-axis. So this means like the derivative is positive. So it's on the first quadrant. On the first quadrant. For where x is positive, f prime of x is above the x-axis. So this is means like if the at x to 1, the derivative is positive. So f prime of x greater than a 0. Look at back the original graph here. At x greater than 0, the graph is increasing behavior at like steeper and steeper slope. If x greater than 0, the f of x exhibiting increasing behavior. And steeper slope. But at a constant rate. But is that like a constant rate? So it's like a knot, it's like and just like steeper, not a constant rate. So it's like, and you can see this is like larger and larger, like more positive. Okay, let's do like another example here. Example 2. Find the equation of the tangent line to the curve g of x equal to x radical x plus 1 at x equal to 8. So it's like the same thing, just to find the g prime of x first. This right, just to conjugate the radical, just to conjugate. Then then just to cancel, do everything. And I just want to give you guys like advice that the one important factor determine whether you do well in calc is like your algebra skills. Because there are like a lot of skills like integrals and derivatives that heavily rely on pre-calc and algebra. So just make sure you have a solid foundation of how they're doing all the calculations. Because I don't want you to lose some like easy point. Because I know you guys want to get a 4.0. And if you make any like computational mistakes, lose those like easy point, well, I just can't have this guarantee to you. So this can be x minus h minus x minus 1. So we have this mess. X plus h plus 1 minus x minus 1 over this mess h over x plus h plus 1 plus x plus 1. Just do more algebra is complicated. This page 28. We go to like the limit. H of 0 gonna be x and x canceled. Become h plus 2. H over x over the radical of x plus h plus 1 plus x plus 1. Cancel out the h. Just equal to like a limit. H approaches 0 is 2 over like a radical of x plus h plus 1 plus x plus 1 is going to be, so it's just going to be 2 over radical 2. So it's going to be x equal to 1 to radical 2. It's just going to be g prime of x. It is 1 over x plus 1. That's its answer. Oh crap. So at x equal to 8, g prime of x, it is 1 over 3. And putting the geometry context that there is a horizontal asymptote at x equal to -1. So this is graph of geovax. It can be like a 0, can be like a -1. There's the horizontal is a vertical asymptote. Then 2. So just gonna be like the Z trend. Well, I'm sorry for this. So this vertical asymptote at x equal to -1. So we can do about this, and it's like a decreasing trend. And at x equal to 1, it is still positive. So this is just never negative, because like you can't have anything that is like slower than like a -1, because inside of radical it must be like that. You must be this, that's be true. And this is always true that like it's just like the man. Just and it's -1 is the whole asymptote. And it's a whole way positive, and it's all the way but closer to a 0. So it's like a less positive, like a less steeper, less steep slope. And we have is the g prime of x. We can just imagine just what is g of x. So g of x is about like a -1 here. This is like less and less steeper slope. So it's like the g of x. And you can see it is increasing. For all real numbers, for just like this. But it's like less steep. So but it's less steeper slope, but still increasing. So this is a graph of like that is what is the gx and the g prime x. It's like you can see it's like increasing less, just like a less more positive, right? Okay, let's just do kind of like another example, but this time it's like no algebra, just use the knowledge, and it's like some of like a concept. Just to match the graphs. So what I would do it is draw a few figures. See if we can figure out this like what is those graph look like. So number one. Just gonna be number two, and number three. Still working on there. Number three. Number four, the last one. Then look at number five. Sort of being like the slower here because number five is just want to be make sure it's like for six. Number seven. Number seven, just increasing and number eight is last graph. Number eight is just okay. Well, let's try to solve. Actually, number six is just not joint to scale. I apologize for it. So for number one, so look at the graph is increasing all the way. And if you take the derivative, it's like people just have them all matched. It's like increasing all the way. And the slope is more steeper and steeper. And then it's like a one, it is matching number eight. If you see number two here, it is horizontal tangent line here. Horizontal tangent line is when the derivative is a zero, and it's a more steeper and steeper, it's decreasing, it's a more negative. And if you look at the old graph here, I mean number five is decreasing all the way, right? Number five is this is prime x. Their derivatives are more steep. So number two matches number five. And this number three, it is increasing horizontal tangent. Horizontal tangent is when the derivative is zero, then hit a zero by like here. Hit a zero in the first quadrant, then hit a zero and the horizontal tangent again. So the derivative hit x-axis twice. It is positive, it is positive, negative, positive again. So it's positive, negative, zero, negative, 0 and positive. So number 3 matches number 6. For number 4, it is increasing all the way, but it's less steep, less negative, but it's still positive. Less positive, but it's like still it's like the surface is more closing to like a 0, but never approaches a 0. So it's increasing but less steep. So number 7 is the graph that matches number 4. So like the derivative it is a positive, but it's much steep. So number 4 matches number 7. That is this question. And then example 4. Sketch the graph of f prime of x if f of x it is x squared minus 8x minus 28. So we first of all find what is f prime of x. What is like slope by tangent line? So in this case, it's 28 to 4 and 7. It's not like a factorable, so we can't find what are the root, what are like a 0, but like we find the derivative. That is the first thing we need to do. It's like and the 0 gonna be x plus h squared minus 8 x plus h minus 28 minus x squared minus 8x minus 28 over h. Wow, this is long, but it's unavoidable. I'm sorry, guys. I know you want to use derivative rules, but well, there's nothing you can change about it. I apologize for it. Minus x squared plus 8x plus 28. Make sure don't mess up with the signs. H. Feel like the limit. X squared canceled, 8x canceled, 28 canceled. We have a 2xh plus h squared minus 8x minus 8h. So we have 1, 2 terms cancel. We have 4 for 9. So we have 3 terms left. Just equal to like the limit. H approaches and the 0 is like 2x plus h minus 8. It turns out that f prime of x, it is 2x minus 8. So now we could do more like smart, kind of a better way to sketch the graph, because before just intuitively just guess where the function is increasing. So in this case, we'll just factor the function here. So for negative infinity to like a 4, for prime of x, it is a negative 4 x equal to 4, at prime of x is a 0. So it's this horizontal tangent line. So for 4 and infinity at prime of x, it is positive. And I can just factor like where like 0 is. If we put 28, we just well, if we plug like a 0, it is negative 28. We plug like a 1, it is negative. With 1, it is negative 35. So it's like, what's more like this? So this is the more like graph of like go to x squared minus 8x minus 28. Here is a 4, and so at the point it's going to be 4, 16 minus 60, negative 44. So at the point 4, so at 4, going to make a negative 44. F of x has a horizontal tangent line. And you can see after x to 4, the function is increasing, but it's more steep. X less than 4, the function is decreasing, but it's less positive. So we can say that the derivative is a linear function. So let's sketch f prime of x. It's a 2x minus 8. Not to scale because I don't have like a ruler. Gonna be 4 and a 0. Let's see that is negative is below. So we just say this is prime of x. Okay, so let's do like another example or do a summary. Summary what we did.
So here's like f of x, f prime of x.
So for any of f of x, it is increasing the derivative is positive. Above the x-axis. In case 2, we will say the derivative is f(x) have a horizontal tangent line, have a hill, or it's a horizontal. Horizontal tangent is 0. If we take the cases that is decreasing, then it's negative. Below the x-axis. This is all rules for 2.8, and next section it is 3.1. You can use the derivative rules. Yes. And thank you so much, and hope you guys have a good day.